All right, let's see if it works better this time. Hopefully it works better. So, the last couple of streams, it was a while ago, but I was trying to learn how to do Hugging Face, sort of how to fine tune and train models using Hugging Face. And that's what I was thinking we will continue doing today, because I want to learn sort of how to fine tune Hugging Face models, and I'll use Lightning for it. And I was thinking, like, for a small project, we'll do a news article summarizer, which we kind of started with last time. So that's the plan or the goal of this, and so it'll be a pretty chill stream, I think. I don't know how I get it's always hard to get the chat for some reason. Like, usually pops up like on OBS, but it's not doing that. So whatever. I'll just get the chat here so I can see it. All right, cool. All right. So also, I don't know if you I have not tried out PyTorch 2.0 actually, but PyTorch 2.0, the stable version, was released I don't know how long ago, 2 days ago maybe. And so I was thinking we'll use that as well. So it'll be PyTorch 2.0 and also Lightning 2.0. There's been a lot of things happening this week actually. So I was thinking just re-download an environment. Let's see. Flant 5 for training. We can check. Sure, we can use this. So the T5 is an encoder decoder, so it'll probably work, right? Let's just install Torch 2.0. It'll be exciting too. Maybe we can, I don't know exactly how much faster PyTorch 2.0 is. PyTorch 2.0.
Welcome to
Torch
A100.
Like, I don't know how much to trust these though, like the speed ups. I like that it's fully backward compatible, and then it is sort of the only thing is torch.compile, right? All right. And we'll need Hugging Face as well. PyTorch Lightning. Okay. Yeah, I mean, it's probably, I mean, for the thing we're trying to do. Okay, so the goal is not to build the best news article summarizer. Actually, I don't care too much about that. Like, the goal for me is more so to learn the overall structure with of how to train models with Hugging Face. So, you know, that's, we will use that probably in the future for sort of projects that are actually what we want, kind of. But so this is just sort of a simple task. Okay, good. Let's do pip install transformers. Yeah, I don't think the model matters too much. Preferably, we'll even you know, we won't use it pre-trained, so we'll just sort of take it, initialize their rates randomly, so that we see that everything works. Kind of, that's the goal, and to set up inference and that sort of stuff. And we want to open Jupyter. Nope. Oh, okay. It was almost a month ago. I need to check what we did here actually. So we did a preproc function. We loaded CNN Daily Mail, and then we trained dataset map, remove columns. Then we did a lightning module, and then a trainer. Okay, good. I wrote steps here. Rewrite code to be more general. Data loading should be from disk rather than their load data set and should be on the fly. Rewrite to lightning code. Trainer, etc. using lightning. Compute metric find that we use. All right. Okay, so we actually use. Right. We started writing my lightning module. Okay. All right, let's see if we can run this. we're not using this, I don't believe. So I guess we can remove that now. We can put it here. And let's run it to train. No module named abs1. I think we might need to install that probably. I don't know what that is actually. Okay, there's something that's not installed. Yeah, I do. I use ChatGPT a lot. We can probably do that here too, but there should be like a how to install it for some like HuggingFace, Rouge, or HuggingFace metrics or something. I remember I did this like a month ago, but I do not know what we did exactly. You can ask ChatGPT. Let's see. I'm using with HuggingFace. Okay. I don't know why I don't like this theme for some reason. I would actually prefer it to just be the normal one. Hey, Anai. Oh, okay. Right, okay, we're trying to do... Right, we're doing everything now in Lightning. Okay. So let's go through it. What are we even doing? What are we doing here? Okay, we have warnings, ignore. We use one GPU, import NumPy, torch, dataset. And we shouldn't do this, I think. Let's see now. They actually changed it. So I need to rewrite my code for that. Yeah, I mean, yeah, the llama weights are, you can actually torrent them. So we'll do maybe we can do that later on today. Let's see how it goes. But we could check out that as well. Sex is great. There was like one where, I saw it, but it's so annoying that you have to do it this way. I'm sure I saw it. Like, there's a new way of importing PyTorch Lightning I saw, and that it should not be this difficult. PyTorch Lightning. Lightning in 15 minutes. Ugh. Whatever, we'll just we'll do it the same way as we did before. Who cares? Import PyTorch Lightning SPL from datasets, load datasets, and then we have the model and stuff. All right, so for the Lightning data module, we first have we set batch size. Oh, this is the data module. Okay, we have prepare data, and we just take 10% of each, I guess. The setup, we do a mapping of our preprocessing function. Okay, yeah, because we will change this later on. It's just to sort of get it working, I guess. I'm not sure about this though. Okay. And then we're doing a train loader and a val loader. Okay. And then for the lightning module, and we load Rouge metric, and our forward is just to run through the model with input IDs, attention masks, and labels. All right. So I guess the input is the article, and the labels in this case is the summarized article. And then we output loss and logit, and then in the training step, we run self here. So we run the forward, and then we do log, and then we return the loss. And similarly for the validation step. And then we want to compute a Rouge metric at the end of the epoch. And we are also doing a configure optimizer. And then we are doing this. This should be probably at the start. All right. So then we are setting all of these things. We're doing accelerate GPU, device is 0, max epochs 10. All right, and wonder what's wrong here then. Oh. I don't like working in Jupyter that much. I don't know why I'm doing it now. It's probably just... I feel like it's sometimes easier when you're sort of getting started with something, but then when you're at... like, I'm gonna have to rewrite it eventually. Support for validation has been removed in version 2.0. Why? Why, like, why change the name? Okay. All right. So it is training. What I want, we can probably, should we try with GPT-4 and see if it's able to, oh, okay, it broke. Right. Okay. I wonder what happened here. Honestly, I have to change the theme. Like, I have no idea why they would use these colors. Like, you can't even read this, you know? Oh, it's actually super annoying. Can I just get back the normal one? Reset and font. Actually, I don't like it that much because the colors are kind of messed up. So I'll just use this, to be honest. Sorry that it's white background. And I have no idea actually why this is causing issue. Oh, this is mapping. Oh, okay, okay. That makes sense. I thought this was training. It's not training. It's just the mapping thing, and then it crashes instantly. Okay. All right. So there's a problem with the model when running the forward, and then its list object has no attribute size. Okay. Let's see what actually is being run here then. The type of input IDs. I have to get better at like debugging. I don't know about you guys, but honestly, like, to be honest, debugging for me is print statements. Like, no joke. I know it's the worst, but that's sort of how I debug things. It's a bad habit. Like, I want to, I mean, especially in Jupyter Notebooks, like, how are you supposed to do it? I don't know. I think I will take just like 2% so that it's super fast. All right. Okay, so we have class list, huh? Okay. I mean, that should probably not be... not sure actually what we should have there. Yeah, is there a better way to debug? I mean, using a debugger is probably a good idea, right? Like, you can just like run through every step and then make sure. I feel like there many times you don't even know what you should print, so it's like debug. It's sort of, yeah. There are probably better ways. I would assume in this time, and there's better ways. Yeah, it should be a tensor, right? Not sure why it's not a tensor though. Okay, so we're doing here. So how is this running? It's running like it's mapping it, right? And then we're doing a data loader of this. And I guess we could check. Can we do that? No? Self.train dataset. Okay, I guess we need to run first. Okay, and it's mapping, and then we'll have a data loader and we can check what happens there. Yeah, I just want to understand sort of why it's not, why is it a list to begin with, you know? Really? Your video is lagging a bit, the audio. Your video is lagging, the audio is ahead of the video. Might have to do with like the quality of this one, maybe. I don't know. Is it still, it is lagging on this for sure, but maybe there's a if I don't use buffering, maybe. Is it better or not? All right, let me know if that is better. Maybe there's a okay, so the input IDs oh, all right, good. Yeah, so it's a list of we should do concat probably. Okay, no, not like that. What? So it's a list, and the length of that list is 512. Okay, so we have y 512 max length. that's the attention mask, and these are the labels. Just a bit confused because here we have input IDs and it's a list of tensors, right? And so, okay. These are too short, right? That's way too short. This is not. Let's see if we do truncation false. I don't know exactly what the truncation does, but okay. Each element in list of batch should be of equal size. I'm not sure what the truncation does. And I don't think this takes a batch, does it? All right, so this batch has an article, and this one, I mean, it's a pretty long one. It is really long. So it takes that, and that is oh no, actually, okay, wait. So this is okay, wait. All right, no, it is actually a batch then. Let's see if we do of article. So it's a list and then, yeah, okay. Is it still like a difference? Is there a delay still, by the way, when I'm talking in the video feed? No delay? All right, let me know if there's an issue. All right, you said no, the truncation removes anything more than the max length. Oh, okay. I mean, that makes sense then. All right, okay. So I guess that's, I'm not sure why I did that, but it might be because the T5 small only has that. I'm not sure. But so we are getting an actual batch here, right? We are sending in, what's the batch size though? So print length of batch of article. $16. Just trying to understand sort of the pipeline of this. All right, so we do data module, and then we do data module.setup. So we're running this. And when is this run? So here, oh, okay, here, doing train data.map. Okay, with batch size. Okay, so we're mapping with the batch size. And then we're doing the tokenizer and all of that, right? And so here, batch of input IDs, we're creating a new one. So if we do input.input IDs.shape, and we'll see what we get there. List, okay, it's a list. All right, okay, so here is the first one. Cool, and if we go, so each of them is a list. I think we need to have a collate function, right? Because if we do, like, we need to pad them to some type of size because it's not gonna work otherwise. $512. Okay, so it is truncated. Okay, and then it's padded, I guess. All right, so every one of them is 512. We should be able to like concatenate them, I feel like, right? Yeah, I do think so. I'm not sure what happens here. So we do input IDs, print input IDs of 0. There's something I'm definitely not understanding here. Okay, so here it seems fine. It's padding it to 512. We're getting and then what happens? We're doing train data set. We're doing it on this. All right, so we have the train data set, which is sort of pre-processed, right? And then we're getting the loader on that train data set. And for some reason, we're getting 512 different tensors. Why? Because here it makes sense, I would say. Okay, so 16 batch size, each of them, right, is 512. And then we return the batch. I think that's fine. That's how it should be, probably. And then what? It's going to be huge. That's the entire data set, I think. Yeah. Okay, so it's 5,000 examples in this data set now. And we have the input IDs. And if we take one of them, it's like this. Yeah, so that's probably good, right? Let's see if we do a batch size here of 1. So the data set makes sense. It's 512 because it's been probably sort of padded at the end, or I guess truncated maybe. Oh. Okay, maybe truncated. But whatever, like each of them is 512. And then when we're creating the loader, we're setting a batch size of 1. And then when we do this, it's getting... Okay, and if we do batch size of 2, still 512. This is wrong. This is, I mean, this is not correct at all. This does not make sense to me. Because now we're getting what? I'm actually really confused. Let's see the old code that we did. Here we did the mapping, and after that we did a... Yeah, we just used a sequence to sequence trainer, so we didn't have to do it this way. We just sent in the train data set, so it's not... I don't know what this does with the actual, like how it creates a data loader or anything, really. Because we set the batch size somewhere. Batch size. Batch size. We did not... Okay, we set the batch size here. So something happens in the sequence to sequence trainer. Maybe we can... I mean, there's probably a way that we created that's not correct, right? But we can try and we can ask GPT-4 if it can help. So we want... Let's see, we are... What is the actual issue? The issue is that the... Oh. Huh. So we're doing... Okay. God of War? For because of the music or? Okay, interesting. All right. The issue is we're doing math with batch true, and this will create batches in the dataset itself. Okay, I mean, I feel like we could. Okay. Okay, I guess that makes sense. So if we then do this now, let's see what happens. I wonder too, like, okay, so here, right? This is GPT-4. If we did the exact same thing but with ChatGPT, let's see if it. See, like it doesn't understand it. You see, if this was actually the issue, let's see. No. I guess it wasn't. No. It does not have to do with that, actually. I think both were wrong. But that would have made sense, I think. If that was the issue. Okay. Let's see. So probably no could specify each. Guys, we're gonna get replaced, okay? Let's just enjoy the time we have. We're gonna get replaced so bad. And this is even like complex stuff. Like imagine a lot of people's jobs where it's like more trivial what to do. Things are gonna change, I think. Oh no. Oh. See how slow this is though? I don't know if I want to use GPT-4 that much. It's like super. Wait, now it says another. I see the tensor are not properly stacked. But that would Maybe it makes sense that it has to do with conversion of some kind. Yeah, this is GPT-4. That's why it's so slow. I don't know if this is the best way. I mean, we can try it. Yeah, we can try it. I don't think that will work, but we can try it. To be honest, I don't care that much because we're gonna change this anyways. Like, you wouldn't load the data this way. We would want to download the dataset and make it general anyways. So, all right. Okay. Well, it did work. Guys, we're gonna get replaced, okay? Guys. God damn it. How long do we have until we lose our jobs? How long do you think? Long live GPT-4. It's gonna replace us all. Judgment Day is coming. And OpenAI is building Skynet. The question is, who is John Connor? Maybe we don't have a John Connor. Maybe that's where the movie is wrong, you know? Like what's actually, like, what's realistic is we have Skynet and it just takes over. Like there's no way to compete. There is no John Connor. And we're just doomed. Yeah. That's probably how it's gonna go. Well, at least we have today, alright? And probably a little bit of time left. Well, what did it actually do then? Okay, so it did the pre-processing and then it set the format. To be honest, I don't care this much because I'm gonna rewrite this anyways. I just wanted to actually train to get the stack working, so we can do. Maybe we can ask GPT-4 to rewrite our code to make it cleaner and better. Can we do that? It has a huge context now. Oh, okay, it did work. No. Missing required positional argument outputs. All right, let's see. All right, so no, that's wrong. self.validation outputs. Let's see. We're on. Oh. I mean, we can try that probably. I did think it would be would need to send it in, but are you a PhD candidate? What do you mean candidate? I'm doing my master's thesis right now. So it's running one validation, and then see, like, it makes stuff up. This is still gonna be the problem, but you're gonna get a lot of apologies. Like, it's not gonna work here. To access output, save them in memory as instance are. What? All right, so what we need to do, initialize empty lists, and then training step, in validation step, we append them, and then we reset the instance. Okay. I don't know. That feels a bit. I guess that's how it is, but wonder why they do it that way. Okay, if we do that anyways, then okay, let's try that. No. Can you help me choose the best laptop GPU on a budget for my practice considering training? Well, what is your goal? Why do you, like, what do you need to compute for? Huh, okay. I did not think about doing it that way. That's pretty interesting though. So that's what they mean by instance attribute? I mean, yeah, that makes sense. I mean, it's still probably the same thing. Also, we should probably change this to like, I wonder if you can do like 0.1% just to make it faster. basically, I want to build deep learning projects as a beginner. I want to explore computer vision and NLP use cases at a small scale. So it's basically like what you want to do is just kind of get more familiar and learn, right? And I think that's a good, I don't think you need that much to do that. There's no attribute tokenizer. So I would say, I mean, first, I mean, like probably, I don't know, but I would probably honestly, I'm coding on a Mac, right? And I do like Macs, especially the newer ones where sort of the RAM is the VRAM. So, you know, if you buy 32 gigabytes of, then you can do a lot of exploration on that. And I think the Mac sort of the MPS, or is it called MPS? Like the Mac equivalent of CUDA, or using CUDA, that will probably only get better. And so for sort of that, what you're thinking of, I would probably buy a Mac, to be honest. But you know, then you get pretty incredible battery life and so on, which is nice, and sort of a nice working laptop. If you buy sort of a laptop that has a 3080 or something, or 3070, I would imagine that consumes a lot of power. So you would, I mean, it would probably be just bulky, and it would probably also be quite bad a battery life and so on. So that's the reason I wouldn't use that. Where's the tokenizer? Tokenizer? Oh, did I remove that part? No. Okay, so I have the tokenizer here. Okay, I just need to do tokenizer. Who do you think will win the AI race? I actually don't know. I mean, I think it will take a long time. Things will change so much, I think, before. But OpenAI probably, maybe right now. It's wrong. I wish you could sort of go back here. Like, they should add a functionality where you can delete these, right? Because now, right, what's happening is that it's doing these were sort of mistakes, and I was asking a separate question, but I would sort of like to remove this box and this box and this box, and just go back to this right here and use that context instead of sort of rewriting the entire thing. So that's so the error is here, right? Join with format torch. Of IDs? Where do you mean? So I mean, this is a tensor already, right? This is a tensor. Wait, hold on. I'm a bit skeptical about Mac. Well, just a bit. I'll check this. So let's see. All right. So what does we get here? The logits, right? We want. Yeah, we need to take the argmax. I do think. Maybe he was right here. Yeah. Okay. So maybe he's right. Yeah. Probably actually. No? Oh, okay. Same again. Jesus, come on. This is why I don't like doing the load dataset this way. It's like you're loading the entire dataset, mapping everything, but it's so slow. Yay. Yay, it works. All right, let's do this. Boom. That's awesome. I am a bit skeptical about Mac, as most frameworks like PyTorch have integration support for NVIDIA hardware. The Apple neural engine is yet to be a full-fledged. What's EP in Torch? Well, yeah, I understand. Like, you should be skeptical, but sort of for training stuff, I would not use Mac. But I think for your use case, you just want to sort of experiment and learn, and I think Mac can be great hardware for that. Actually, I would at least look into it. My idea is to get a future-proof compute. Okay, well, I think okay, so like you can train stuff on a Mac now, especially if it's not like really well, okay, what do you mean by future-proof? Because you will not be future-proof with a laptop anyways, right? At some point you're gonna want to train and run stuff that has, you know, if you're gonna want to like fine-tune a llama model or something, or a large language model, then you're gonna have to have like, you know, a lot of VRAM. So if you're buying something that has 8 gigabytes, you're not future-proof anyways. You're sort of okay with being restricted and that, you know, if you need something for the future, you'll rent it, I'm assuming. And that's a good way to go about it. It's not a bad way. Is it improving or not? Like, the argument I would have is that if you're using a Mac, then it is improving, right? Yeah, we're like saving it as instance variables and then we're removing it at every validation. Yeah, I guess it's improving a bit. Let's stop this now, though. And let's also set to use this device instead. All right, and while this is running, let's do it this way. All right, okay. Let's see. Okay, so yeah, okay, so I was saying about the Mac, okay? Assuming that what you want is to experiment and sort of learn machine learning and deep learning, I definitely think you can use Mac for that. Like, the counter argument would be that there's a lot of it's not as MPS is not as robust and tested as CUDA and NVIDIA hardware, and I would agree with that. But on the other hand, you don't need that. Like, you can and sort of, if you're thinking future proof, it's only gonna get better. So if you're thinking of like what you get, then you're getting, to me, from a laptop, right? You're looking at a laptop. To me, the Macs with the M1, M2 chips, you know, they are probably the best laptops right now. And especially when you're considering that the RAM is also the VRAM. If you buy a 32 gigabyte, you get 32 gigabytes of VRAM. You can do a lot of exploration on that. So like hardware, you're getting really good performance. You're getting insane battery life. You're getting, you know, a really polished product. Like, I'm a fan, to be honest. Like, there are cons of Macs, and I don't like that you have to buy like a million gadgets and shit for it, and that's annoying. But like, they are good. There's no denying that. Like, it's a really good laptop, and I would definitely consider buying that rather than sort of some 8 gigabyte 3070, and you're gonna get like this bulky machine that has like 1 hour battery life because the GPU is gonna consume so much. All right, so what do we want to do now? We want to check. We want to overfit batch. Let's all get comfortable with the fact that the growing concern around AI is misplaced, and the main problem is our own error, which is sometimes an intentional nerf, and we no longer have source. I don't think it's misplaced. I think we should definitely be concerned about many things. Current advancements in AI would be like the Industrial Revolution. I mean, it's looking like it's going to be the Industrial Revolution on steroids, but who knows? It could also be hyped, and we don't know. You know, we'll see, I guess. Yeah. RTX 3070 is fast, Better Life is terrible, and bulky. Yeah, I mean, to be honest, I would definitely look into a Mac, in my opinion. So, or if you're not gonna do a laptop, then just buy a sort of a server or something, or like a what is it called, a workstation. Okay, all right. I want to do here. I want to prog bar true. I want to see the loss on the training. Like, we need to check that we can overfit one batch. And if we can do that, then that's pretty good. No? Where's the loss? Train loss. 15. Yeah, that's not good. It's not really changing that much. I mean, it is changing a bit though. Maybe the learning rate is just a bit. Okay, yeah, we'll probably increase the learning rate. Okay, but it is overfitting slowly. Learning rate finder, trainer tune. Okay, it is working. We will do this and see if we can use that for find the learning rate. How come we don't have that? I don't understand. Trainer object has no attribute tuner. What? It is trainer.tuner. No? Okay. This is annoying because I don't see what I'm doing wrong. This is so annoying. Whatever. I guess we can just use some. I don't think it matters too much. Yeah, it's definitely overfitting faster now, which is good. All right, so let's use this and then let's train it, and we'll change the code to what do you guys think, by the way, if we sort of, I did a PyTorch Lightning series, right? And I was thinking to do a HuggingFace series where we sort of, but I'm not really sure what would be, what is interesting to know about HuggingFace, sort of how, what is the goal if we're thinking like a HuggingFace series or like tutorial series. What is it that we would actually want to learn? Like personally, like I would want to learn training or sort of how to train a model, but I mean that's what we're doing now, right? But also like how to use a pipeline. I would like to know like what is HuggingFace. I would like to know what tasks can we do, how to use pipeline. Yeah, I'm using the latest one. It's 2.0. So how to use pipeline, how to train a model. Like how would you, if you were thinking like just, if somebody like, okay, here's a good series of videos on how to learn a HuggingFace, what would you want to learn? What would be a good structure for it? All right, we'll rerun this and we'll let it train a little bit so that we see that it works. And we need to create an inference step as well so that we can send in text of our article and then it will summarize it so that we make sure that it works. So if we're just looking like, okay, what we want to do, sort of like step, or we want to create an inference step. So send in news article, get summary. We would like to change the data loading so it's more general, meaning on the fly loading from disk. We would also I don't know, like clean up the code, make it into script instead of a notebook. What else? You didn't have a tuning video on the Lightning series, you mean? I can make another video on that. And like tips and tricks, but if we're looking at, I would like to learn how to use Hugging with data that's not in Hugging Face yet. Yeah, okay, so I mean that would be, the thing is though, like, would you prefer to do, because you can do custom data set loading, right? You can always do that, but would you want to know how to load data sets with Hugging Face, I guess? The thing is though, like, I don't think this is general, you know? Like, more general is loading it yourself from scratch. They have sort of things you can use for this, but I don't. This is PyTorch 2.0 actually, but I'm not sure how we, I guess we'll see how we use that. I don't think we're using it now with the torch compile. But if we go to sort of the Hugging Face tutorial here, right? If we use this as inspiration, like what they did, they go through like how do transformers work and so on. They do like what tasks can we do, how to use pipeline and tokenizers. Yeah, I'm not sure how one would structure this. I mean, lower level pipeline usage is like, how does pipeline work actually? Lower level. That could be, that's what they do here. And then they do a fine tuning of a model, sharing models, dataset library. You know, another thing probably, right, is that I could do this, like I could explain these things and give like an introduction to them, and then we could rather just do like small example projects, you know? Like we could do, instead of like how to train a model, right? We could do building a news article summarizer, right? We could do something like that, and that would be like one video. We can do another project that would like showcase exactly what it is we're trying to learn through examples. But I don't really know what we would want to learn, right? I need to learn it myself. But if we're sort of thinking the bigger picture, right? What is it that we would want to actually do? What would be useful to people? That's sort of the question, I guess. For me, what I would want, like right now, is this. I personally want to use Lightning Trainer and Hugging Face models, and how we fine tune and train with that. Like that's to me one of the big things. That's what we're trying to do now, so that's why it's interesting to me. Wait, what happened? I restarted it? Huh. Like the Lightning Trainer is a lot more robust and it's a lot more tested, and just it's better than the Hugging Face Trainer. I mean, there's just the best option for training things, it seems like to me. So I mean, you can, like, they show you how to use the Hugging Face Trainer, but I don't feel like it's, I don't know, I don't like it that much actually when I've tried it. So all right, but this is what we want to do. let's see, model name T5 small. And where are we loading the model? Here we're doing that. I want to yeah, I don't know about that actually. I think that's it's probably fine. We can probably use it. But give me some like if you have any thoughts on what would be useful to for people to actually like what would a good series be for Hugging Face? And so tell like imagine how you would what you would want to learn, right? So we're sort of starting with the end in mind, which is how would a good structure look like, and then we can reverse engineer and learn about those things specifically. So like I guess like first principles, what would you actually want to be able to do with Hugging Face? I mean, I feel like this would probably be the first one, like what is Hugging Face? Because a lot of people probably don't know what Hugging Face is. What can we do? What's available? I mean like what common tasks we can do with Hugging Face, like probably taking a look at you know, like the models here. We can look at text classification and sort of an overview of tasks. Yeah, Hugging Face can do a lot. I mean, I would probably just like try to give an overview of what we can do, and maybe like an explanation of and explain the tasks briefly, like what they are about, like what is question answering, etc. So that would be like the then like using the Hugging Face pipeline. I feel like that's a really good high level feature. This would probably be good, like how to know how it works on like a lower level. Oh, it's taking this long to load the data. Damn. Yeah, we need to change the data loading. It's gonna take too long. Okay. But that would probably be the fifth one. Then like 5. Let's start from RNN, LSTM, BERT, distill BERT, and so on. That would be more. That wouldn't be Hugging Face specific though. Like that would be more, NLP playlist, right? That would be what has been the advancements in NLP. What can we do with NLP? What models exist in NLP? If we're sort of looking at Hugging Face specifically, we want to learn how do we use this library for getting stuff done in tasks that we want to do. I think probably, honestly, like we can probably use like similar structure as they do. Hugging Face metrics. Token. Well, I don't know. Tokenizer. And like Hugging Face trainer. I think probably like this, putting it together to fine tune a news article summarizer. That's what we've done now, right? But then making it more general and robust with Lightning and custom data loading. Like same project, right? The news article summarizer. We do it first with Hugging Face, and then we try to make it more general with custom data loading and robust with Lightning. What do you think about that? Is this a good, would this be a good playlist, you think? So first, like what is Hugging Face on a general level? What can we do with it? Like what tasks exist and so on with the models. And then sort of overall using the Hugging Face pipeline, how we can input like what model to use, maybe even like some type of arguments for the most common tasks. If you're using a language model like temperature and so on, and sort of getting an overall idea of those, and then how does it actually look like on a lower level? Like what does pipeline actually call? Like what, like tokenizer, all of these things. And then, I mean, we looked at this on live stream, I think, a while ago. Here, yeah, this like auto model tokenizer, getting probabilities and all of that. And then understanding like, okay, what exists in Hugging Face datasets, Hugging Face tokenizer, and how does the Hugging Face trainer work? So you can use just Hugging Face for training everything, and then we put it together to do like a small project, and then we make it more general. What do you guys think? Like, would there be anything? Should we do another project as well to make it to really like? Or are there other concepts that we need to learn? Like maybe there are more things one would like to know about like probably, right, we would want to have also Hugging Face evaluate, probably. Has anyone done, I mean, tutorials or something? I feel like this is useful for people, or it would be useful if we would make this. PEF. I don't know what that is. What's that? PEFT method? I don't know what that is. Can we use a different language for the news article summarizer, you mean? Yeah. It wouldn't be, I don't think, it's just that we like we want to know like the results, like how, if it's good or bad. And the dataset I think is in English, so I mean I don't think there's an equivalent for other languages. I don't think. Well, probably if we search for it. Took an efficient net pre-trained model for transfer learning. My train loss is 0.5, val loss 0.2, and accuracy train is 93, and validation is 98. I'm testing for input images from different data set, not from test val. I'm getting wrong predictions mostly. Well, first of all, it's a bit strange that you have such a big difference between your training and val. That should not be the case. It should be the opposite, the way around. I'm actually quite confused how your training accuracy is lower than your validation. That's a bit strange to me. Might be something wrong with the sort of approach there then. But if you are, let's say that you are, I mean, if you're getting wrong predictions from a different data set on the same type of images, then there is something fundamentally different about the images, I'd say. And like, okay, so I mean, you could, if you're create like a separate, I mean, that would be your test set, right? So you have validation and then you have your test set, and the test set is then those images that you scraped, or sort of from a separate data set that's to test the sort of generalization accuracy. So your question is basically, okay, my train accuracy and val accuracy is a bit strange, so there might be something wrong in your training approach, but then the test accuracy does not follow, so it doesn't generalize. My guess would be that you don't have a robust validation set, first of all, because if that happens, then it means that there's something strange about the val. Like, there's something wrong about the validation dataset. Maybe it's too small, and that means that it's not. But yeah, that would be, your new dataset is too different from the one you trained your model. That would be my guess as well. Oh no, Jesus Christ. That was a mistake. I did overfit batches 1. Yeah, we need to change this because it's not gonna... Yeah, actually, if you have any questions, I'm gonna, if you have any questions, I can definitely answer them. I've thought about this a lot. And so I would say, personally, I would say it seems like your model is overfitting on the training data, and that leads to poor generalization on unseen data. And overfitting occurs. Yeah, the most performance on different is not robust. You need to have more diverse data, regularization. I'm surprised that let's see. All right, so we want to change now the data module. We want to create a custom So let's say we have a train CSV, test CSV, and val.csv. Each has the column. The task is to use PyTorch and load using a custom dataset. And then we want to create a PyTorch Lightning data module that uses this custom dataset to do on-the-fly loading with tokenizer on-the-fly loading, and it is using tokenizer, which is already defined and is a HuggingFace tokenizer. That should be enough, right? Can you write the code for doing this? Call the custom dataset CNN Daily Mail, and call the Lightning DM my data module. What do you think? It will be able to do it, I think? Where did the chat go? Did I close it? What? I closed it? Okay. That's not good. Okay, I need to bring up the chat. Let's see. There we go. Pop up. No, I'm not that good. I did lead code a long time ago when I was like preparing for interviews, like technical programming interviews. I got to the point where I could do, like with some time I could do the medium ones, and like I was touching on doing some hard ones, but they were really difficult. I'm definitely like not that good now. I think I will need to practice that a lot. Okay, let's do GP. Let's compare, by the way. So if we do this, all right. And if we do the same thing with GPT-4, I don't think we should compete with GPT-4. Like, we should just learn how to use it. The end goal is just to be more productive, right? And whatever accomplishes that goal, I think is fine, to be honest. Like, we need to learn how to use new tools, and so I don't think it's actually that big of a problem to. I mean, we'll probably get replaced pretty soon, but I don't. It will take a while, I think, and we will learn how to adapt. It will just create new jobs, I think. Okay, so it works. We don't need to do that tokenizer. Okay, so we have that, and then we should probably, let's just do like a copy of it. Duplicate, and let's do CNN daily T5 lightning custom data loading. Okay, good. I mean, this simplifies so much. Now it's like, I wonder though, like what we would have, like what would be the, is it data loading actually an issue now or not? Not sure. I don't think it will be, but maybe. We can probably take this away, and then we can do this. We can move this down, and that's it. And then we have that. If we don't do overfit batches and we just run it, ever tried using forward for propagation? No, I have actually not even read the paper for that. That's pretty slow, right? I think maybe the batch size is an issue, probably. We can try and we can do batch size equals a little bit higher maybe. And we're also using numWorker 0, so it's probably gonna be bottlenecked by data loading. We can check here probably. Watch NVIDIA SMI. Oh, it's using 18 gigabytes. Wow. Well, that's a lot. Did it crash? I think we can probably clear the output of this one. And let's rerun it. I mean, now it's not doing the mapping, so it's gonna be fast. Okay, we can't do that. And here we have another batch size. We're not using this, are we? Yeah. Let's remove that. What do you mean live updates? Like it updates every 2 seconds by default. You can do watch 0.1. Okay, I actually don't know. There's a way of like specifying the interval. All right, cool. So we get that. There's definitely a data loading issue, right? I mean, we can do the profiler with Lightning, and we can also see exactly how things are going, but I'm pretty darn sure that it's a data loading issue here. Because we have num workers set to 0, so. But it's probably fine. I would like to do, like if we take, yeah. Alright, so I mean this, we've done that now, which is good. And then we gotta do an inference step now. And this is slow, right? This is really slow. Let's see if we can improve that. Torch.compile HuggingFace. How do we do that? Opt module, torch.compile module. Let's do PyTorch Lightning. I wonder if we can you use num workers in a Jupyter notebook? I don't know if you can actually. Do you guys know? It does? Okay. Well, this didn't speed up anything though. Like it'll just slightly. Not much. Okay. So this is interesting. Let's see if we can do Lightning PyTorch 2.0, and we'll see sort of a realistic example, I guess, of if we can do sort of torch compile of the model. All right, so it took 1 hour and 20 minutes. Let's see if we do torch compile, if that changes anything. This is taking a long time. All right, let's see what we get here now. You can use mod in instead of pandas. Right here. You mean this instead of locate? I wonder what takes time now. Like where do you mean that this would be the bottleneck? It's definitely a lot slower now to getting started. I don't know if it's because of the torch compile, probably because it was faster just a second ago. And wait, oh, wait. Okay. Yeah, this is torch 2.0. We're just checking if it's faster, but it doesn't seem like it's faster. At least this part didn't help, so maybe it helps to do it sort of earlier, maybe if you do when you're doing the model somewhere here. Maybe if we do this instead, that maybe helps. Yeah, it didn't really help much. Yeah, Lightning 2.0 and Torch 2.0, both. Maybe we can ask people like what I'm gonna make like a community post to ask about what people would want from a Hugging Face tutorial series, because yeah, definitely need to plan it a bit on what exactly would be good. Yeah, I don't know. It didn't really seem to make that big of a difference to me, so I don't know.
PyTorch 2 was introduced last.
How do you lower things here? Whatever, it'll just be loud.
Week. It's faster, more Pythonic, and as dynamic as ever. You can already use it and test it, but what are the new features? The main new feature is torch.compile, a compiled mode that accelerates your model without needing to change your model code. In the tests, it could speed up training by up to 76%. It's an optional feature and hence 2.0 is fully backward compatible. For example, you can also immediately try this with Hugging Face models by adding this one line, underpinning torch.compile.
All right. Welcome, everyone. Good morning, good evening, depending on where you are. Product that's supported nightly installed. The future webinars are going to apply even at Inference. You can check if you're facing the same error as I did. I guess that's not happening today, at least not on my dev environment. But I'd encourage you to see if that works on your end and if it runs fast, as fast as we hope it to be.
This is gonna take too long though. Well, we can probably. Where did you see 70% faster?
And like amp precision, this gets
Doesn't seem to be I mean, this does not seem to be the. But what we can do also, I mean, we're not even. We're doing precision. We should do precision 16 here, right? Maybe that'll make it faster. I mean, it will at least reduce the VRAM, so we can use 32.
%86% on TorchBench and 62% on HuggingFace. And really, consequentially, that means if your model training is running for 5 days, now it runs like 62% off. No, it's 60% faster than 5 days. It's like 3 days or something. So I think that's like real meaningful change in your productivity with this kind of stuff. And like the way we could, do an aggregated speed up is like 75% of AMP and 25% of float 32. And that's something we established when we started this effort. It's not something we did post hoc. And we kind of are luckily looking at like reasonably good speed ups. Now, caveat. These speed ups are on A100 GPU. If you try it on a desktop GPU like an NVIDIA 3090, the speed ups are going to be slightly lower. And that's just that the faster and bigger the GPU, the more eager mode cannot keep up, and we need to introduce a compiler. So if you're using a GPU that's not that doesn't have as much like where PyTorch is already doing a reasonably good job, then like you're not going to see as much. But like I think they're lower, but they're still pretty good. So with all this, we were all pretty confident that this was a solid mode, and we are actually introducing today torch.compile within the PyTorch framework, and it is available in the nightlies today. And that's something that we want to ship into 1.14. And we have a few modes. We have a mode for smaller models, like if you just have a tiny model and it's mostly framework overhead bound. We have a mode to like purely reduce overhead, but it trades off some other things. Like it takes a little bit of extra memory, but if it's a small enough model, you don't care. And then we have a mode that takes very long time to compile, but it will give you slightly better performance. And the default mode tries to just sweet spot everything. It takes about like 10 to 30 seconds to compile on average, and it doesn't take extra memory, and it kind of gives reasonably good speedups. Now, we have a few backends, but like Inductor is our default backend, as I said. And we support dynamic shapes, but dynamic shape support is very early. It is not yet ready for like consumption, but like when we actually do a stable release, it will be. But just one cool, my slides are here. One cool graph is we actually validated it with, say, GPT-2 training, and it does look pretty impressive. It's the thing in pink. And you can compare it with a commonly used trick in the industry called static shapes as padding, where, if you have dynamic sequence lengths, you just like statically pad them. And like dynamic shapes by natively will actually make a meaningful difference in performance versus doing static shapes and padding. And Horace actually will talk later today in more detail about this. And then lastly, we have full graph mode. By full graph mode, we mean you either compile the model as a one single whole graph, or you give an error message. This is like a more traditional compiler. And that's kind of useful for certain backends, like say TensorRT, who don't like partial graphs and stuff like that. So the way you think about it, we're going to have eager, which is a default, but you don't get a bunch of performance benefits. And then torch.compile by default will emit partial graphs, and you'll get most of the benefits, except for like a little bit, like you can't export it to mobile, and like you can do some very advanced distributed parallelism. And then you have torch.compile with full graph mode, which might involve you changing your code a little bit, but it can give you that last mile 5% performance, or you can export it to a very large device and things like that. So in some near future, and Michael Seal is going to talk about it, we will have a torch export of your model so that you can actually export it and send it out to a different backend completely. And in some far-flung future, we will have torch.compile not just wrap the model, but also wrap the entire training loop so that you can get more fusions across, like you can fuse the optimizer in and things like that. So distributed works. And not only does it work, it has great speedups. These are AMP speedups with distributed data parallel. And you see some models are like, I don't know, 15% faster. Or some models are like 80% faster, kind of. So if you make the model faster, the communication starts becoming more of a bottleneck. So at some point, we got to figure out how to like carefully adjust that as well. But the other interesting thing is actually like if you use FSDP distributed mode, and you train any of these models, like because of the fusions and like carefully like managing and reusing memory, it takes lesser memory. So like so the TIM's vision transformer large, it's taking 70% of memory compared to eager mode. So you can actually fit a larger model in the compiled mode in certain settings like these. So that's kind of cool. And even in the compiled mode in non-distributed, that's something that we expect to an extent, though it's not fully true today. So the compiler that we built, it has a solid set of debug tooling, or at least like an early solid set of debug tooling. We have a minifier that actually, like, if you have an issue and you want to report it and you have a big code base, you invoke the minifier. It will reduce your problem to a small code snippet that you can post on GitHub and things like that. Just to summarize, we are introducing torch.compile in 1.14, and on our original goal of optimizing these 163 models. It worked out of the box without any change 93% of the time, and it works 43% faster on average in the aggregated performance numbers compared to eager mode on an A100. So, okay, first, there's a lot of new stuff to take, and the room is like, okay, like I'm overloaded, like can you like calm down? So let me just like step back and say this is all gonna land in 1.14. It's available in our nightlies today, and we're pretty excited about that. But then one of the things I was thinking is like, oh, actually, like the way users are gonna use PyTorch is gonna fundamentally start changing. Like they're gonna use eager mode for most things by default and experiment and stuff, but anytime they start doing a large training run, they would want to switch to compiled mode and wrap their model in the torch.compile. And this is meaningfully new experience. It's not in terms of you using PyTorch, it's not going to be the same way as before in some deep way. And I think we have a road to showing substantial speedups, and we have our initial numbers today. So I was like, why don't we just call it 2.0? I mean, it makes sense. Like, we should just call it PyTorch 2.0, and we also can stop having those long version numbers for a little bit. And so
Yeah, I did
we
not
are
do a
going
good
to
job
actually
here.
call this 2.0.
It's easier to just do it yourself here, I think, to be honest. All right, what do we want? We have model.py. And we do these, that stuff, batch size in the data set. Need to send in the batch size here. No. Actually, no. Yeah, it just did it. It just did it completely wrong, to be honest. All right, let's do it ourselves instead. So we will want this. That one, and then we want to have this. Oh. Hmm. I'll just be right back. I'm gonna make some lunch while it is running. But the next steps here, I want to create an inference step. Definitely. We changed the data loading. We want to clean up the code so it's and then we want to see how we can make it faster. Maybe multi GPU training. Probably. Profile. We want to add profiler to see if it's okay. And we want to add TensorBoard visualization, random or not use pre-trained weights, but from scratch to ensure that training setup works. That's probably it, right? I'm gonna continue though. I'm just gonna take a quick break and I'll be back. I don't think it's worth to. I don't know if I should pause the stream and then continue, or just. Not sure.
Oh, and within the two series of within the two series of releases, we have a bunch of stuff planned around performance and compilation and scalability. We have some codes from people who have tried this. First from Sylvain, who's a primary maintainer of HuggingFace transformers, who tried it, and he, in his own words, he said, hey, I added one line of code, and it's like 1.5x to 2x faster in the models I trained. And that's like a good validation that it's not just us pretending to say that it works and you have to believe in the room.
All right, be right back.
Luca Antiga, who's also here, says nice things. I will let you read it for a sec. But basically, we've tried to validate it with some of our most power user PyTorch customers, and they seem to agree that this is a solid direction and this is a nice thing that they would support for PyTorch to go into. Ross Whitman, who is a maintainer of TIM, also tried it, and he basically is like, it just works with majority of TIM models. I didn't really have to change any code or have that experience that I had with, say, torch script kind of thing. Now, what else, right? Okay, we're going to deliver 2.0 stable release in the beginning of March. And it's available in the nightly starting today, and you can go try it. And obviously, like, it's going to break in many million ways, and you're going to be like, oh, Sumit, like you said, it's going to work. So file away those GitHub issues. And in the rest of the 2.x series, we're going to release 2.0 stable early March. And in the rest of the 2.x series, we are working on, as I said, the stable primitives that I talked about, export mode, support for more accelerators and backends. And I think, and we know how we can get a lot more speedups than we have today. We have a bunch of ideas around compiler optimizations. And there's a bunch of ideas here, actually, that we want to do, but we don't have the bandwidth. And now that we've built this entire compiler stack in Python, and it's easy to contribute to, even though it's conceptually it's a compiler and it's like hard as in general, we would love you to take part. Like, come help us build this thing, file a GitHub issue on what your plan is and what you plan to improve. We have, what's my next slide? Oh yeah, we have a Q&A webinar happening over the next month or so, where you can talk to the devs directly, maybe discuss some of the ideas you want to implement. So 2.0 is fully backward compatible by definition, and I want to say this out loud because people will say, oh, 2.0, does this mean I have to rewrite my code? Despite everything I said in the slides, I think that's easy to misunderstand. We didn't do a rewrite. Like, it's the same code base. It's the same code. It's just we're introducing a new substantial feature in compilation mode, and that's fully optional, and you wrap your model explicitly to get that mode. So your code base worked as is. I mean, we were going to call it 1.14, and then we're like, oh, it'd be nice to call it 2.0. So it's fully backward compatible. So before you go on Twitter and be like, is 2.0 fully backward compatible, or should I rewrite my code? I'm telling you up front. Try it today in the nightly binaries and give us feedback. And we have a bunch of deep dives starting from the next talk on how each of these technologies actually works under the hood. And don't miss our Ask the Engineers series that is happening starting this month online. And also we have some office hours if you want to try it out today in the afternoon and you have questions with, you can bring your laptop on. At the back, we're going to have the office hours later today. With that being said, I will start handing it off to Peng Wu, who will deep dive into Torch Dynamo.
I was waiting for all this talk for him to utter the word PyTorch 2.0. And finally, he said it. Welcome to PyTorch conference. This is my first one. I'm Peng Wu. I support the PyTorch compiler team. So as a compiler person, PT 2.0, to a large extent, is really a compiler story. And you might wonder, why does it take so long for us to actually fully embrace compiler technology into the core of PyTorch? And the reason is because what makes PyTorch beloved by researchers is flexibility, dynamism, expressiveness, is exactly what makes it very hard to compile. So it took us 5 years of developing various solutions, compiler solutions, to get to where we are. And I want to call the inflection point of our journey searching for the right compiler solution Torch Dynamo, which is what I'm going to talk about. So it starts with asking this question: what is one thing that we could change first in the compiler stack that will fundamentally change the efficiency of PyTorch? It's not a new compiler optimization. It's not even a new compiler backend. Actually, the key first move lies in the top part of the compiler, which is the graph capture. So we all know that graph mode execution can be a lot more efficient than executing ops one at a time, especially if you are a machine learning accelerator designer or if you are a production engineer. Unfortunately, for eager first machine learning framework like PyTorch, it's actually non-trivial to get graphs reliably. So that's why we care about graph capture, because it's simple. If you don't have reliable graph capture, you don't have a reliable compiler coverage. So let me introduce Torch Dynamo, our first out-of-box graph capture. Here's one example of a toy PyTorch program. And here is this one-liner change, torch.compile. And in this example, we actually allow you to specify a custom backend. And in this particular example, my compiler basically takes the graph that's captured by Dynamo and do something about it, which basically print it out and return a Python callable. So if you execute this program, you'll be surprised to see actually 3 graphs being printed out, because in this example, we actually put a twist of a data-dependent control flow. So this graph break actually is a feature, is a fundamental design feature of Torch Dynamo that makes it out-of-box and sound. So let me double-click on what makes Torch Dynamo sound and out-of-box. Number 1 is partial graph capture. So this is our ability to skip anything unwanted and then fall back to eager. And with partial graph capture, we save the programmers to have to shoehorn their models into what the backend compiler wants. Instead, we're just seamlessly transiting in and out of between eager and the graph mode. And then there is the guarded graph generation. Basically, we want to make sure whatever we are capturing at capture time is still valid when we're replaying this graph. And finally, if we did find a mismatch on the guard, we have the ability to just in time recapture them. So basically, partial guarded graph capture with just in-time recapturing is what set Dynamo apart from all our previous graph capture technologies. And by the way, there's this thing called AOT autograph that captures the backward part of the graph, and that makes it working for training. So I want to show you some numbers, which Sumit already highlighted in his keynote, that would back the claims we made so far. You have seen the 7K plus model, so this demonstrates that it indeed works.
Welcome to the
and right now we have more than 20
I don't know what to call it, the team,
backends for inference that's
the family
with Torch Dynamo, and we have more than one backend that's integrated with Torch Dynamo.
Thanks for
training.
supporting
and the
the
number
channel.
is smaller on training side, not because of Dynamo, but because they're just
What's Torch Dynamo? I've seen that a lot of times.
of training into the have a vibrant, thriving, and
faithfully capture.
All right. Just trying to think a bit like what we want to do now, because I mean, like, this is working now, right? Which is good. And I think probably like the first thing we need to do like is clean up the code, right? We need to that would be the first, right? And then we need to train for an epoch. Second would be to create an inference step. Check that it works. Check that it works. Okay. So yeah, let's like the training part is just this basically, right? Oh. Is this? What? Do you guys have an idea why this is happening? Like, it's always happening for me for some reason. Like, I'm doing command copy. If I do it here, it's gonna copy the URL. Like, it makes no sense. If I do this, copy, I think it works. Okay. And if I do this, it copies the URL. Like, I have no idea how that even, how did that happen? Like, how did that happen? I don't know. I actually don't know. Do you think I'm hacked? Like, has somebody hacked my computer, you think? So strange. Oh, I don't know. All right, so here we're doing lightning module. We need to import those, right? So import like that. And we need to create a tokenizer as well. I'm just gonna have to do this. No, this is okay, wait, actually if I do this, like if I copy this and I do this, okay, that works. Maybe that's why. I mean, this is but it should, no, I've not had this issue before. Like, there's something wrong for sure. All right, and then we need to have the model. What else do we need to do? We need to have we need to have the tokenizer as well. Oh, all right, and then the data set. We need to copy paste all that. And probably run this as well. Actually no, let's keep that. But we need to have this for the data set. All right. So CNN Daily Mail data set, and then the data, my data module. We're gonna need this as well. Good. Is there anything else? Probably. Data set. Okay, wait, it actually seems to work. Okay, so let's so we're running it here now. Alright, we'll wait 40 seconds. Cool. And it should be done. Oh no. Huh. Yikes. Yeah, the non-workers was working actually. That surprised me because it didn't. I've had issues with that before, so I don't know. But it did work now, so that's good. Alright, whatever. We'll just clear this then, and we will go to our, let's do tmux new. I always forget how to do that. I can't remember at all how you do that. Tmux new session HuggingFace tutorials. Oh no, what happened? Yeah, I'll reduce it. I think it's because of, I don't know why. I guess the validation is taking more or something. Tmux detach. Alright, tmux attach session HuggingFace tutorials. Yes. Alright, there we go. And then what do we want to do? How did you even, oh, it was such a long time ago I actually used this one. Like that and this, and then we want to move it. Forget the key bindings. And then we'll do train.py here. And if we use multi-GPU here, so let's just check. It's 2.75, 2.8. Let's see when it sort of stabilizes. And one thing I'm curious about is how much did torch compile actually do here? So if we don't do this, if we instead do that, and we just set the model like that, I wonder how much slower it is. It seems to converge at around 3. I don't know. Like if it's a huge difference, I guess we'll notice. 1.5 minutes. It was like, it was about 3.5 after 1.5 minutes. Oh, it's running. I don't know what happened here. Three oh six six five. Okay, good. Oh no. All right, it works now, right? Let's add the other stuff we want to do, which is what did we say that we wanted to do? Clean up code, train for an epoch, add multi-GPU training. I want to add tensor board visualization. Yeah. Let's see how we do that. I don't really remember. Here we go, logger. Okay. So we're logging all of that. We can probably do it much nicer. We don't have to do it logged like this. You know, that's really unnecessary, I think. But this is probably fine. And so we should have TensorBoard, I think, now. Do we want to do anything else? We probably have TensorBoard. Uh, uh, let's see. Hi, I just hopped in to tell you that I've been following your lightning tutorials. They're amazing. Also love your dedication in the live stream. Yeah, I'm happy that they're helpful. I wanted to learn lightning myself because it's a really great tool. So I'm happy that it made it easier for you to learn. And it's similar thing that like what I want to do now. I want to do like a HuggingFace series so that people can learn it easier and get a better understanding of it. I think I'm gonna post later on a community post sort of the general structure of HuggingFace tutorials I was thinking of doing, sort of, and then we could sort of what people would think would be a good idea for that, because it's useful to get input on what would actually be sort of a good structure for it. But yeah, thanks for the kind words. All right, so check with the TensorBoard visualization. We want to add random weights just to make sure that it actually works too. So it should hopefully work now. If we do train, all right. So what do we have? TB logs, TensorBoard logdale. No, we're not gonna have that. Okay, so we need to do. I think we need to do something like this. 6006. Let's map that to 16,000. All right. So what's next? We cleaned up the code. We did that. Multi-GPU training, let's try that. So let's see if it's faster with multi-GPU. Train. Hmm. I don't think that's a good idea to do it this way, because like in now with the model, right? When it's saving the stuff for this, I think this is probably we probably have to do that. Probably. Because it seems like it's just going to increase the VRAM usage. Yeah, it just increases and crashes. So it doesn't have to do with this. Yeah, I mean, it's probably already doing that because it's in the validation, I would assume. Actually not sure what's causing this. I don't think it's the batch size, because if it was the batch size, then I mean, we can try, right? We can try reducing it, but I'm thinking if it has to do with like stacking of some kind. See, it's crashing again. It's just like it doesn't have to do with the batch size. I did this another time though. I remember when we fine-tuned Whisper or whatever. Okay, guess we didn't. Oh, it's working now? No, it crashed. Alright, so let's just go through. What are we actually doing? In the model here, it probably makes more sense to store self.logits and self.labels, and then here probably add them. All right, so we've detached them. We have self.logit, self.labels. And then here we're gonna have to decoded preds, batch decode. So what are we doing here? We are taking the argmax. Now we've appended all of them on the validation, right? Okay. Okay, well that made a difference. I guess there was something wrong with that then. Okay, cool. I mean, it's not that different. Like, all I did here is, yeah. All right, this is pretty fast. And let's now do trainer fit. All right, so I don't know, it takes about 45 minutes or something. Let's see what it takes if we use both GPUs. Hold on, it's actually slower. I don't think that makes much sense. Guess maybe the data loading will be limiting, perhaps. Mm-hmm. Okay. And if we do it with random weights, that's probably the next thing we want to do. Because now we're initializing like this from pre-trained. We didn't change anything, did we? Just the compile thing? Maybe that... All right. Let's see now. So we have this. And let's see what happens. Started at 1.2. The previous one. Started where? Okay, it didn't start as high. So this is randomly initialized, and that's good, so that we yeah, I guess actually have something that makes sense. Now the question is, what do we want to do when it comes to... I mean, this is probably like too large, like it takes too long time. If we could reduce... All right, let's do that. So it's a lot faster, and we'll see that it makes sense. And we want to add a inference script for a predict function. So for our model here, G, copy it. Oh. Can you also perform CUDA programming? No, I mean, I've never coded in CUDA. I guess I'm mostly just concerned with Python. All right, cool. So it should be a lot faster now. And can we get an update here? There we go. Where's the purple one? Where is it? There it is. There it is. We have one. Okay. Wait, what happened there? It increased? We'll see what happens. What? Come on. So annoying. Alright, there we go. I don't know why it's so sensitive. Oh. Alright. I mean, this is not that great. Okay, this looks better. Yeah, we're gonna have to wait a bit, I think, to actually check that it works. Okay, this is good. This is random initialization too, so this means that it's you know, it's working. So that's nice. We'll run it for a bit and then we'll see how the Rouge score changes.
What is the Rouge metric? For many NLP tasks, we can use common metrics like accuracy or F1 score. But what do you do when you want to measure something like the quality of a summary from a model like T5? In this video, we'll take a look at a widely used metric for text summarization called Rouge. There are actually several variants of Rouge, but the basic idea behind all of them is to assign a single numerical score to a summary that tells us how good it is compared to one or more reference summaries. In this example, we have a book review that has been summarized by some model. If we compare the generated summary to some reference human summaries, we can see that the model is actually pretty good and only differs by a word or two. So how can we measure the quality of a generated summary in an automatic way? The approach that Rouge takes is to compare the n-grams of the generated summary to the n-grams of the references. An n-gram is just a fancy way of saying a chunk of n words. So let's start with unigrams, which correspond to the individual words in a sentence. In this example, you can see that 6 of the words in the generated summary are also found in one of the reference summaries. And the Rouge metric that compares unigrams is called Rouge 1. Now that we've found our matches, one way to assign a score to the summary is to compute the recall of the unigrams. This means we just count the number of matching words in the generated and reference summaries and normalize the count by dividing by the number of words in the reference. In this example, we found 6 matching words and our reference has 6 words, so our unigram recall is perfect. This means that all of the words in the reference summary have been produced in the generated one. Now, perfect recall sounds great, but imagine if our generated summary had been something like, I really loved reading The Hunger Games. This would also have perfect recall, but is arguably a worse summary since it is verbose. To deal with these scenarios, we can also compute precision, which in the Rouge context measures how much of the generated summary was relevant. In practice, both precision and recall are usually computed, and then the F1 score is reported. Now, we can change the granularity of the comparison by comparing bigrams instead of unigrams. With bigrams, we chunk the sentence into pairs of consecutive words, and then count how many pairs in the generated summary are present in the reference one. This gives us Rouge 2 precision and recall, which as we can see is lower than the Rouge 1 scores from earlier. Now, if the summaries are long, the Rouge 2 scores will generally be small because there are fewer bigrams to match. And this is also true for abstracted summarization, so both Rouge 1 and Rouge 2 scores are usually reported. The last Rouge variant we'll discuss is Rouge L. Rouge L doesn't compare n-grams, but instead treats each summary as a sequence of words and then looks for the longest common subsequence, or LCS. A subsequence is a sequence that appears in the same relative order, but not necessarily contiguous. So in this example, I loved reading The Hunger Games is the longest common subsequence between the two summaries. And the main advantage of Rouge L over Rouge 1 or Rouge 2 is that it doesn't depend on consecutive n-gram matches, and so it tends to capture sentence structure much more accurately. Now, to compute Rouge scores in the datasets library is very simple. You just use the load metric function, provide your model summaries along with the references, and you're good to go. The output from the calculation contains a lot of information.
All right, so after running it now, we'll try this predicting, and we should be able to get a summary. I think, let's see what we wanted to do. We added TensorBoard visualization, right? We also did so that it did from scratch. We also now created an inference step, and we'll skip the profiler, I think. So, I mean, actually what we want to do now is, we want to try it, check that it works, the inference step. But I think probably check if article is greater than 512. Truncating, maybe it causes issues if the article is much longer. This is like one idea I have. If it's a lot longer than 512, then maybe that will cause an issue. Because we're truncating it anyways, so like maybe if it's like 5,000 and we're getting a very small chunk of the article, but yeah, should probably be fine maybe. Okay, good. So I mean it's increasing at least. Not that much though, but a bit, I guess. Yeah, I guess it needs to run a little bit. Mm. Oh. I don't know where it's saving this. Hmm. It should be in the lightning logs, and then we have a bunch of different versions here. Let's see. No, like what? All right, I'll be right back. I'll let it train for a while. I'm just gonna get a cup of coffee. Okay. And this is improving as well. I don't know what good is, like what. And we're only taking a small part of the data, and we're only using T5 small. I don't know if I'm looking for the best results here. I'm kind of just wanting to make sure that it is sensible and you can use it. So let's see if we can I guess find out which model version we should use here. Wait, did I not save the model? Hmm. I would think that it's this one probably. No. Hmm. Like I have no idea which one it is. That's the problem. Actually, can I do this and then is it gonna get an error now? Probably. All right. Well, I think this is probably like we need to check like how to actually make this a lot better, right? But as a basic sanity check, it definitely seems to work. We'll try the predict thing. I just want to have the checkpoint. I really hope this works. Let's see if we get an error or not. No, it doesn't save it. What? Are you serious? It does save it though. Like, where does it save it? And if it doesn't save, we're not going to be able to use it. This is not good. What's going on? Let's see. Let's change it even more actually, because I think let's just use a very, very small part. Okay, so we need to do, you know, we need to run the, or like know how to load it. Load a model. Okay, now let's see. I mean, it needs to save it, so I don't know. It doesn't save it. Or it saves it at some other place. What? I don't know if I want that. I just want all I want is to save the like the checkpoints to this one. Oh, it's here that it saves it? No. No. Okay, it saves at the end. Well, I don't want that. Really? You have to do that? That feels a bit complicated to have to use a checkpoint to save it. I'm not sure if that's what I did a long time ago or when for the lightning. Let's see, train. No, I did not use that. It does save it though after every epoch, so a bit confused. All right, so if we have, let's see, we have the no, yeah, so it should say now, like it should make a warning, you don't have the lightning logs folder, right? Same thing as it did here. It warned here. Oh, okay. Uh, I guess the problem is here. There's no checkpoint here. Alright, this is slightly frustrating because it should be able to save the model pretty easily. I'm not sure why I need to do this even. And we also have it verbose, so it should definitely tell us that it's saving too. Thank you. Next. Yeah, this is nice. So we now have checkpoint and we have this thing. Let's see, is it any good? Probably not. All right. Why did it log? Oh, what the hell? I don't know how it should be formatted exactly, but like something like this maybe. Hello. Hydrant from Tesla. That would be pretty hard, man. What? We did checkpoint. Kurt Duck. CKPT. CKPT. What? Hmm. Missing 3 required. Well, I know I definitely did this. It's pretty scary how fast you forget things, to be honest. This was like 2 months ago or something. Even less than that, probably. Mm. Okay, let's see. I don't think I really get it. So wait, we need to have init here, but we have already initialized it. All right, fine. Let's try this then. All right. Well, it did run. Let us try if we get better results here. And let's copy my model epoch 04 to current.ck. There we go. And then let's rerun it again. Let's see. Wonder how long this is like would need to train to actually get something that's reasonable. Like maybe this is not all right, something like this. Well, it should be possible to, I feel like. It could be that it just needs a lot more time to train maybe. We're using just a small piece of the data, right? That could be it. But I don't know. Oh, wait, I didn't even send that in. Maybe that's why. But, yeah, I don't know. Oh, yeah. The A. Yeah. So this should be from the training data. Like, I mean, like, this looks pretty okay. I mean, like, this is pretty good. And this looks pretty good, but the performance is god awful, so. 2. It makes sense. I just made a text classifier with HuggingFace. Did you train it as well? Or like, how did you use it? how did you do it? Or for what? But it's just doing the AA like all the time, so there's definitely something not right. Maybe I should copy checkpoints because it's a little bit better now, probably. I mean, it is getting better. I just think it needs more time. Yeah, I just think it needs a lot more time. We're training on a very small subset of the data, and we haven't been training. I just think it needs time, probably. Yeah, I mean, it is moving in the right direction. I'll train this, and then I'll continue from this probably. But this seems to be, I mean, we got pretty damn far, honestly, so this is really nice. And I think the next step is just to make sure that it works. I think I will post sort of a community post thing about, let's see, this, because I'm thinking of like how to structure the HuggingFace tutorial series, and it would be nice to get some feedback on like what would be good and bad and so on. All right, but it's gonna take too long to do this. I don't think we can do much more either now, because now I mean, it actually is running and working, and I don't think there's anything that I can, let's see. I don't think so. Yeah. All right. I would say that was a good day. It's definitely productive. Cool. Cool. Nice. All right. I think I'm gonna end the stream there. We got pretty far, and I think we can start thinking about a like how to plan a tutorial series on HuggingFace and do some project as well. It would be cool to do some nice fun project. This was maybe not like, well, I guess it's pretty interesting. All right. Thanks to everybody who joined, and remember to subscribe with notifications, or I will contact the gradient gods and make sure that yours will vanish. And it will be unexpected. Like, training will go perfectly. You will like not think of anything that could go wrong. Your accuracy is 99%, and you just want to get to just a little bit higher, and then that's when your gradients will vanish. But they won't vanish if you subscribe. All right. Have a good day, guys.